This is Javier Valiño from Atos, and I am heading the unit for energy, climate, and decarbonization inside Atos Research and Innovation, which is the innovation hub we have in Atos for the Atos group, through which we are going through innovation projects such as Sphere and some other projects that we have presented on some previous presentations. And given my background in digital technologies, let's say my professional role as part of the energy unit, I am going to present some ideas on how can we combine all these things together, starting from digital twins and buildings, but also trying to expand it a little bit, as Valentina did, for instance, in her presentation earlier, how to expand this picture and make sure that whatever we are doing, and that we are doing very nicely regarding digital buildings, can be also expanded outside the building with the connection to the different energy grids, also with the connection to the electromobility sector, which is very important with electric vehicles and so on. And also with any other kind of digital data that we can use to optimize everything at once and not just trying to make small optimizations at each domain level. So that is what the presentation will be about, and hopefully
Javier,
yes,
you are coming from Atos, and this is
right.
A consultancy company. Why a consultancy company is interested in digital twins?
Well, I think Atos it is much more than a consulting company. Well, it is, you know, a very, very big company, more than 100,000 employees in 70 countries. And we are not just providing consultancy services, we are also directly developers and providers of digital services and digital technology. So we touch upon from the hardware level, we use HPCs, we develop these quantum technology computers, and we are moving to the software part. We are ranking as experts in Europe for cybersecurity solutions, also digital workplace and everything. So what we try to do as an innovation department is trying to make sure that we are on the state of the art of all these digital technologies so that we can apply them in different industries. And for instance, in my case, energy is the industry I am targeting with these solutions, and energy is very important in buildings because most of the things that we are trying to optimize through digital twins are based on energy efficiency. But there are also other solutions. Oh, I see I can share it now. So hopefully you can see also my screen now.
Yes, now that's perfect.
Great, great. So let's move directly to the presentation. So
so let's.
Great. So let me try to elaborate a bit more on this expanding the picture concept. So we have for buildings, we can have small buildings, smart homes at user prosumer level. We might have big buildings, which are somehow aggregating several dwellings, several prosumers all together. We might have energy communities that are made up of several individual smart homes from prosumers. We do have as well public-owned buildings that are forming a single energy network, and we might have as well smart cities or smart districts. And as we are growing on scale, we are also growing on the amount of flexibility they can provide, because in all those cases, those buildings will have small generation capacity, some flexibility on the way they can consume the energy, in some cases as well some storage capabilities, maybe some small fleets of electrical vehicles. So there is a lot of flexibility we can provide, and we are becoming experts with digital twins in optimizing the way those buildings are operating. But we are focusing this concept usually from the perspective of the building operator itself or the community operator itself. trying to optimize the way they are producing, consuming, and monetizing energy so that they become highly efficient. But maybe we are trying to optimize small problems rather to optimizing the big problem, which is really the connection to the grid. So those buildings are connected to several grids. They are connected to the electricity grid. They are connected in some cases to centralized district heating and cooling networks. They are connected as well to water energy networks. So in essence, buildings are a scaling down opportunity that it is representative of a big concept, which is the overall city, the overall country, which is made up of individual buildings together within several networks altogether. So there is a lot of room for studying business cases, potential new technical use cases that can be easily tested in buildings using digital twins and can be in the future be scaled up and tested at larger levels. Some of those use cases, for instance, peer-to-peer trading of energy between different owners or flats in a single building, or different owners on a community, or different buildings in a district. So we can test it, because at the end of the day, there is no regulation whenever we are applying energy transfer in this small network. So we can test it and prove it that it is meaningful. We can also play with demand side management, what we were discussing earlier. We can build a digital twin so that we optimize the ways we are consuming energy and trying to make it as smart as possible. We can involve the DSO, so that's the complexity level is increasing. If we connect to the grid and the DSO, the distributor, is aware of what we are doing, not just in our building, but in all the buildings that they are controlling, we will be able to optimize not just our building, but the whole network, and provide flexibility and ancillary services directly to the DSO. We can also tackle this, as anticipated by Marcia in the first presentation, from the social perspective, taking users at the center, and how to make some services that are oriented for their engagement in these energy efficiency policies. We can play as well with energy storage, for instance, deploying batteries that are not owned by a single consumer, but rather owned by a whole building of different prosumers aggregated, or a small community, and therefore they would need to share it, and they will have to book it, and they will have to reserve some slots for charging and discharging. We can also, and this is very important, we need to control how buildings are connected, so that we maintain always the power flow voltage levels, so that this connection to the grid that might be going in and out is properly controlled. And finally, we can also envisage some use cases that are spinning around electric vehicles. So this is also an overlap of with another sector, not just with energy, but also with mobility. How do we see the future, or how are we doing it right now? So we have some ICT ingestion engines deployed at building level with IoT devices, with SCADAs, and so on, so that we can gather as much information as we can. And this is consumed usually locally, or if it is not consumed locally, it is consumed on a dedicated cloud server, which is just for this building. Or in the most advanced cases, for some building managers, it is gathering information for the set of buildings that they are managing, but that's it. But we have the same in different other sectors that might be overlapping. We have this as well in place for mobility, for health, for agri-food, for energy, and those systems do have information that might be useful for us as building operators, and the other way around. We are gathering information that might be useful for them as well. So what is the way forward we see? Trying to break these silos and try to make those systems operating together. How can we do so? With the principles of data spaces. Data spaces, at the end of the day, what they are asking us as operators for a building platform is to deploy a connector which will be able to talk with some horizontal services for gathering information or for proving identity, sharing the same vocabulary, what we already discussed about in ontologies and common information models, make it aware for discovery of data, and also providing some basic maintenance services so that we can share on a service and data marketplace on top of those services all the information that we are gathering. So at this stage, we are applying digital twins at this level, so at building level, and we are very good at optimizing a building. But it is time for us to move the concept of digital twins and apply it at horizontal level, so that we are considering not just the building, but everything that is affecting the building in the context. And this is also an opportunity for us as a digital twin for building operators or creators to monetize this data. So it might be the case that we are gathering data which is valuable for others, and they will be willing to pay for this. And we can use our own data, and we can also monetize our own data. So we see this as the future for this sector. Why do we think that this is the future? Because there are also some supporting movements, let's say, at European level towards this. This was already mentioned by Valentina as well. There is a strategy for data which is issued by the European Commission a couple of years ago, in which they are pushing for the single digital market. So what they are saying is that they want to have at European level a single data space that is aggregating data from every sector. And they are funding a lot of projects as we speak in order to do so. They are starting sector by sector. For instance, they are funding projects for data spaces at energy level, or at mobility level, or at health level. But the next round of projects in 1 year time, 2 years time, would be for the cross collaboration of those data spaces towards this final data space, unified data space at European level. And this data space should be following these rules that they have been drafting through this strategy for data, in which we can exchange non-personal data. That's very important. We can exchange quality data. So it is not just every data we can imagine. Whatever we disclose, whatever we share, should be quality, no? And we should respect the European values, which is privacy, trust, sovereignty, and so on, which is very, very linked to the GDPR. This is okay, very quickly. So this is the way or where we stand, let's say. Usually we operate everything either as infrastructure as a service or platform as a service at building level. So the goal would be going up on the sovereignty stack and move forward to the data spaces. This is also supported by GAIAX, as you can see here, which is the Association for Data Spaces at European level, in which they are considering, as you can see on the top, several verticals, and buildings are covering several verticals at once. As you can see, it is covering energy, it is covering mobility, it is covering smart living. So it is very pertinent to buildings. This is a slide also extracted from the European Commission, in which they are saying how data spaces in energy should cooperate with different things. And as you can see, they are willing to see sharing information about renewable energy, electric vehicles, smart homes and buildings, and sector coupling. And we have everything on our buildings. So that's very important. And last slide, as also anticipated by Valentina, we are coordinating as Atos OmegaX project, which is specifically regarding data spaces in energy. You can see we started this month, and we will last for 3 years. And it is right about this. And we have several use cases inside the project that are working directly with digital buildings, and how to use this data and combine it with other data, with other contexts, so that we make sure that we are providing horizontal services that are more intelligent than the ones that we can provide by just optimizing the building itself. So thank you very much for your time, and I will be happy to answer some questions either now or later.